Alright, welcome back. We are in the garage today, but not doing car stuff today. Out of the cabin we have this sign in the bush. Not that bush, like landscaping bush.
Oh, okay.
It's made of wood, and because wood is weak and pathetic, it's rotten and not very sturdy anymore. It's served its purpose, but we're going to make a new one out of steel, because steel is manly and it won't rot. Before we get started with that, we're going to do a little welding 101. I'll catch you back here in a little bit. Through the power of editing, we're gonna step out of the garage and into my studio. You can tell it's a studio because I have a sweet mic. It doesn't even work. And a whiteboard with stuff on it. I even have a computer over here that you can't see, so I can fact check myself.
That's not true! So get your facts straight.
So like I said before, when it comes to cars and automotive stuff, I am not an expert. But when it comes to welding, I'm also not an expert. I am, however, a AWS certified welder and an AWS certified welding inspector. All that really means is I passed a test after I gave the AWS a bunch of money. Still doesn't make me an expert, but I know a little bit.
I'm sorry, all I heard was blah blah blah, I'm a dirty tramp.
So, what is welding? I did not check and see what Webster says, but I'm going to tell you it is a permanent process of using heat to join two separate pieces of metal together. I say permanent because, I mean, technically it is permanent. You can separate them once they've been welded together, but we'll just call it permanent. Welding is a very broad topic, plenty of rabbit holes we could definitely go down. We're just going to do a very high level overview. Normally, well, in all the options we're going to talk about, electricity is used to generate that heat to bond the two pieces of metal together. In order to fuse the metal together with the welding process, for A36 steel anyways, it melts at 2500 to 2800 degrees. Most welding, like we're going to be talking about, the arc temperature is anywhere from 5500 degrees all the way up to 1100 degrees. I also have shielding gas up here. Shielding gas is required while the weld is being deposited. The air around us has too many contaminants in it and it will cause weld defects. I blame that on all the smog that California pumped into the air up until the middle 90s.
Beverly Hills, California.
They got swimming pools and movie stars.
And smog.
Weld defects is another rabbit hole that we're not going to go down today. The first one we're going to talk about is shielded metal arc welding, also known as stick welding. Stick welding used to be very common in production welding, infrastructure welding. It still is used mainly in infrastructure, building erection.
Jesus Christ!
What is
He's
it?
got an erection!
Not that kind of erection. Stuff like that, but is not used in production welding as much anymore. Shielded metal arc welding uses a flux-coated welding electrode. As the weld is being deposited, that flux burns, and that's what creates the shielding gas. It also mixes with the weld puddle as it's being deposited. As it cools, it raises to the top and brings impurities with it. That flux later on has to be removed or chipped off. The next welding process we're going to talk about is gas metal arc welding, also commonly referred to as MIG. MIG stands for metal inert gas. Gas metal arc welding is considered the correct term. Somebody with a doctorate in metallurgy probably decided that, so we're going with it. MIG is also used commonly, and if you refer to it by either one, people will know what you're talking about. MIG welding uses a spool of wire. It's a steel wire that has a protective coating on it. It looks like copper. I think a lot of people are confused and think it is copper, but it's not. It's actually steel with a copper colored coating on it.
Stop it. Get some help.
And then MIG welding uses a cylinder of gas to provide the shielding gas while the weld is being deposited. So no flux. There's nothing to chip off after you're done with a MIG style. There's different styles and processes of MIG welding. You can have electrode positive, electrode negative. There's constant voltage. There's pulse. There's rapid pulse. But again, it's one of those rabbit holes we're not going to go down today. Flux core arc welding is the same as gas metal arc welding, but, and that's a Kim Kardashian but.
That's fine.
So instead of a solid metal electrode, the flux core arc welding electrode is hollow and is filled with a flux powder. Flux core arc welding can be used without a shielding gas, and it uses the flux itself to create the shielding gas as it burns. And then just like stick welding, that flux as the weld cools rises to the top and brings the impurities with it. You can use a separate shielding gas with flux core arc welding. They call that dual shield. But again, you will get the flux that rises to the top as it's cooling that will have to be chipped off. If you're a good flux core arc welder, the flux will fall off as it cools. Good welders know what I'm talking about. And last on the list, we have gas tungsten arc welding. This one is also known as TIG welding. It's very similar to stick welding, but a little fancier. We'll call it bougie stick welding.
I'm getting notes of dried robin's blood, old dirty cashews, and just a hint of a robot's bathwater.
It uses a tungsten as an electrode. It doesn't get consumed into the weld like the other electrodes. You use a filler rod with TIG welding. And then you can also control your voltage with a foot pedal. Hopefully I can find videos of these processes to add in so you can see what I'm talking about. Fingers crossed. There are other forms of welding that use electricity as well. There are stud welding guns. It uses a specialized gun to hold a stud and weld it to like a beam or a wide flange. There's also spot welders. They are used a lot for sheet metal and tin. They clamp the two pieces together and just heat it up real quick in one spot and provide a tiny spot weld. There are also forms of welding that do not use electricity. There's oxy-fuel welding. So you use the same setup as an oxy-fuel torch, but instead of cutting the steel, you use a welding head and heat the metal up enough to melt it. And then you also swirl it together while adding in a filler rod. There is forge welding. That is simply taking the two pieces of metal, putting them in a forge, and then beating them on an anvil until they stick together. Very barbaric. Probably the oldest form of welding, I'm assuming. I don't know. There's also friction stir welding. In friction stir welding, one of the components is spun and pressure is applied to it to another component. Friction from that spinning and pressure heats them both up to the molten state. Then it stops spinning and they are welded together. And there's even explosion welding. Small controlled explosions are used along with pressure to weld two pieces of steel together. Today we're mainly going to focus on gas metal arc welding, and when we get back to the garage, that is the process I will be using to demonstrate with. Alright, so I updated my handy dandy marker board here with some fine doodling, and we're going to talk more about gas metal arc welding. But before we do that, let's have a word from our sponsor. I don't have a sponsor. I'm the sponsor. I'm making all this happen. But if you want to help me out, go ahead and hit the subscribe button. I think it's down there. Maybe it's over there. Wherever it's at. Go ahead, hit that. It's free for you and really helps me out. If you really want to do me a solid, you can log in with your wife's account and subscribe her too. Alright, so here is a typical gas metal arc welding setup. We have a power source here, basically turns electricity into magic. And then we also have a wire feeder up top that feeds the wire through your stinger or lead. There's a ground cable. Again, like we talked earlier, that can be either positive or negative. On smaller units, the wire feeder is integrated into the power unit. It's all one, but for diagramming purposes, I drew it like this. And then there's also a cylinder with a shielding gas, usually an argon mix, can be straight argon, can be straight CO2. Usually it's a mix of those two. And here I have a blown up image of the welding gun. So here's the handle, trigger, the neck. I did a cutaway on the cone so you can see it better. There's a gas diffuser and a welding tip in there. So when you pull the trigger, three things happen at the same time, basically.
You just triggered my trap card!
The first thing that happens is welding gas comes out, the gas diffuser, so it starts shielding that weld before you even start depositing it. Also, when you hit the trigger, it starts feeding wire through, and that wire will come out, and that's what you make your weld with. And when you pull the trigger, it also energizes the welding wire through the tip. So when your piece is grounded, that completes the circuit. Alright, one more doodle board before we get back out in the garage and do some real welding. We're going to talk about weld joint types. Not that kind of joint, weld joint.
Do you want us to make a joint?
So there's 5 different types of weld joints. First one we're going to talk about is a T-joint, and that's literally 2 pieces of steel, one horizontal, one vertical, making a 90-degree angle, or a T-joint. And there's variations of a T-joint. There's an askew T-joint when that angle is not 90 degrees. Again, rabbit hole we're not going down. So T-joint's first one. The next type of joint is a butt joint.
Mother trucker, dude! That hurt like a butt cheek on a stick.
Watch your profanity.
Just like it sounds, 2 pieces of metal butted up to make a butt joint. We'll also talk about prepping a butt joint. There's many different ways you can prep this joint depending on the weld specification. So there's a single bevel, and in a single bevel, just one member has a bevel on it. I don't know if you can see that or not, hopefully you can. But this one would be squared off, and then this one is beveled. There's also a double bevel. You guessed it, both of them are beveled in a double bevel. There's also a V-groove. In a V-groove, both members are beveled slightly at the top, but then there's still a flat land down here at the bottom, making a V, obviously. There's also a double V-groove, and you guessed it, in that one, both the top and the bottom are beveled to make what looks like 2 V's. So that's it for butt joints. The next one is a lap joint.
As I learned about kids jumping on my lap, and I've loved kids jumping on my lap.
So that is 2 pieces of metal, one laying on top of the other, and then it's kind of hard to draw, but hopefully you can see what I got going on there. There's a bottom piece and then a top piece, and where they meet there is the lap. That's where the weld gets deposited. There's also an edge joint. That is just two pieces of metal butted up, and then that top edge is welded. Tried to put a nice little black blob up there. That's my weld. And then last but not least is a corner joint. And that is, you know, obviously two pieces at a 90-degree angle, and then the outside of that is welded. Hopefully you can see my black blob over there. That's weld. So yeah, that's the different types of joints, joint prep. Again, you can go down a rabbit hole on each one of these. There's different configurations for all of them, but we're staying, you know, simple. Keep it simple. All right, let's get back in the garage and get the frame built. All right, we'll go ahead and get this metal part taken out of the wooden frame.
Never gonna financially recover from this.
All right, we're gonna make the new frame from some of this scrap angle I got laying around. There's random sizes and random lengths. Hopefully I can come up with enough to make the frame. I'm gonna make it the opening 19 by 30, just like the old one was, so that cutout cabin piece will fit in there. So let me do some measuring and do some cutting, and then we'll get to the welding. All right, I think I got my pieces here. I think these two will be the uprights. Obviously, I'll have to cut the one down a little bit, but I'm gonna keep them as long as possible. I'll cut a point on the end. That way there's plenty to go in the ground to stake it. So those will be my uprights. These will be my top and bottom cross pieces. Again, I'll have to get those cut down to length, but I think these will be our 4 pieces we're gonna make our frame from. So like I explained to you earlier, this is my Lincoln Power MIG. It's a little guy. It's a 180C is the model number. I don't know what that means. 180 amps maybe. But it is a gas metal arc welder or MIG. And like I said, this one's all in one. It's a power unit, and here's the wire feeder. A little spool of wire. I got 025 on there. And then I also have, I think it's 030. But those are the 2 different wires that I have that I use. And then my gas back here, my argon. I should be running 90-10, so 90% argon, 10% CO2. But the welding supply people gave me straight argon instead. Not a big deal, it'll work for what we're doing here today. So yeah, I'm going to get those pieces laid out, squared up. I'll probably do it on the floor since my table is a little bowed in the middle. It's had some heavy stuff on it. So I'll probably do it on the floor because it's flatter. One thing I forgot to mention on these little guys, well, all of them actually, they have settings. So here's your setting for your voltage. This one goes from A to J. It's not really like, most of the time you'll actually get a heat setting like 28 volts or for like a spray mode, or 19 volts or something like that for a short circuit. This one we have A to J. So here's the wire feed. Normally this is measured in inches per minute. I don't know, like this is just 1 through 10. I don't know that that represents inches per minute in any way, shape, or form. But normally you'd want to go like, for like a spray mode, you'd want 400 inches a minute wire speed with like 0.45 wire. But for a little guy like this, and the stuff we're doing, just crank them both wide open. And then if you blow through, obviously it's too hot and you have too much wire and you can turn it back down. That's what I do anyways. Alright, so I got it all welded up. Do not look at my welds too close. They look like garbage. I'm going to blame it on the straight argon instead of the argon CO2 mix. I'm going to go ahead and get the tabs put on that sign, and I'll get that centered in here and get those tacked on and welded on. And then I think we'll shoot a little paint on this. I mean, might as well, right? Alright, I think I got this about where I want it. Pretty centered. Double check, make sure it's straight. Alright, I think that does it for welding. I'm going to pull this sign piece back out, clean this up a little bit, and shoot some paint on it. Well, I might as well spritz some paint on her while we're at it. It's the next day. Paint is dry. Got it all put back together. Ready to load it up and take it to the cabin. Thank you guys for watching. Everything went really good. Hopefully you learned something maybe. If not, hopefully you laughed a little bit. Until next time, you know what they say.
Thanks for watching the video.
Make sure you follow, like, and subscribe.
Make sure you follow, like, and subscribe to my dad's channel.
Here we go.
Money, making crap for